Hello guys, today I'm going to show you how to interface an LCD 16x2 on a PIC microcontroller. Today we're going to be using the PIC 18F4520. Okay, we're going to be using it in the 4-bit mode. Here I have a file. So here are the LCD commands that I used, and I also have the file. Here I have the header file for the LCD that I'm going to be using to interface in my code. Okay, back to MPLab. Okay, first things first, you start a new project, standalone project. Next, takes a little bit time to load. We'll wait for it. Okay, advanced 8-bit MCUs PIC 18. Then I'm using PIC 18F4520. There it is. I click again next. Then I'm going to pick PIC3 and next. Since I'm going to be compiling using the PIC3, that's why I chose the PIC3. Then I'm going to be using the X8 compiler. Then I click next as well. Then I'll name my project LCD interfacing 4-bit mode. Sorry there for the $sign. 4-bit mode. Then I click on finish. Okay, first things first, we have to make the configuration bits. Try getting more configuration bits. Okay, I'm going to be using the internal oscillators as usual. We'll also make a tutorial in the future of how to use the external oscillator. Okay, want to configure all pins as digital on reset. Then we're going to use the internal oscillator block port function on RA6 and RA7. Then LVP single supply ICSP enable bit. We're going to turn this off. Then we generate our source code to output. We copy everything that is generated. Copy. Then under header files, now new project. We create a new header file. We name it configuration. I just name it config. You just enter. Then I'm going to select everything that I have in this file, then paste. Okay. There I have my configuration bits. The next thing, I'm going to include my LCD header file. Okay, now I'm going to add the file that I've shown you, the LCD header file. I've put mine on the desktop. There it is. Then you click on copy. For you to copy the file, the header file, into your directory of the project, then you click on select. Okay, there it is. Now I'm going to make a new file, the cmin file, where I'm going to be doing most of the main program, as in the main methods and everything that is going to execute my program. Okay, I'm going to name mine main. It must have an extension of C. Then I'll click on finish. Okay, you don't need that. Also do not need this. Okay, first things first, I have to include the PIC header file. So then I'm going to be using the PIC 18F4520. Okay, PIC 18F4520. Then next thing I'm going to include the configuration bits. Then I'm going to include the LCD 4-bit header file. Then from that, I'm going to make my main method. Okay. Then my main method, first of all, since I'm going to be using the internal oscillator, I must set the oscon register. Oscon register equal to 0 x72. By the way, this is in X format. To initialize what? To initialize my PIC microcontroller to use the internal oscillator at a frequency of 8 megahertz. Next thing, I'm going to initialize my LCD. LCD initialize. Then after that, I'm going to go into my main method where I'm going in the while one loop so that it loops forever. Okay, now using our header file like I've shown you before, we have some methods that we are going to be using. Like you see in here, we have the LCD init, LCD command, and what, but we are going to use this one, LCD string, because we just want to print something on the LCD. So LCD string, LCD string. I'm just going to print varslabs. Yeah, by the way, you can use any character, but you must mind the length of your string, your message, because since this is a 16 by 2 LCD that we're going to be using, your characters must be at most 16 characters must be in the string. If you exceed that, then the rest of the characters are going to be truncated on the 16th character. Therefore, you must make sure that your characters are less than 16 or equal to 16 for you to present them all. Next, I'm going to use I'm just going to introduce a little bit of delay. I want to use some of the functions here so that you can see. Alright, let's have something here. I must enter the delay I want. Okay, I'm just going to put 400 there. Then the other thing is this function here, LCD string, it just goes on the last point where the LCD had a character, and then it prints from there. Meaning to say, if I start using it right now, it means it's going to go on the location 0, the first box on my LCD. That's what it's going to print. But if I repeat using this function, it means that it's going to print on the last character, in which case will be what will be the S on the labs here. So it will print varslabs again, it will print varslabs again, print varslabs again if I loop this one. But now I'm not going to do this. I want to show you another function, which is the LCD string XY. Okay, now this function is a little bit different. You actually give it the coordinates you want to print it. Like here, I'm going to be using the location 1, 0. 1 will be what? 1 will be the row, and 0 will be the location of the column that I'm going to be printing something. As you can notice, I did not put the LCD clear. Why? Because if you put the LCD clear, yes, it will clear the screen. But again, if you try to write something on where you have written before, it's going to overwrite what is there, and you write something else. It means that what you've put to be written on top of something, that is what is going to be displayed on the screen. You won't see the previous thing that you have printed before. So I'm just going to write again varslabs. Okay, for the sake of the tutorial, I'm going to write something else. Just going to write LCD 4-bit. Okay, so you're going to notice that when we run this code in Proteus, you find out that it will first of all write what? Varslabs. Okay, I did not put a delay there, therefore it means it's going to just flash and won't be able to fully view the won't be able to fully view the LCD 4-bit because since it's looping, it was going to go on this part, on this part, and after this part it was just going to jump over and come back here. So this LCD, this delay, MS delay, is going to allow us to see this part, then it goes back there. Okay, so I think that's what we need for this tutorial. Okay, I guess that's all. Let us compile the file. Okay, it's compiling. Okay, LCD clear is never used, but that's fine, doesn't matter. Okay, we've built successfully our code. Now we're going to move over to Proteus. Okay, now I've opened my Proteus, click on new project. Okay, I'll just pause this. Okay, it has finished loading now. Okay, I'm going to name my project LCD interfacing. LCD interfacing. Click on next. I just want the A4. I'm not going to do that big. Do not create PCB layout. No frame project. Click on finish. Okay. Now let us bring the components we want to use. I want to use the PIC 18F 4520. Double click it. It's there on the list of components we want to use. Then we are going to need the LCD, and it's called the LM016. Okay, there it is. Just double click it. It's there. Then that's all we need for this project. Okay, I place my PIC there, my LCD there. Okay, we're going to be using the port D. Let us go back and show you. Okay, the RS is going to be connected to lat D, which is RD2. Then EN is going to be connected to D3, which is RD3. Then our data is going to be connected on port D, the rest of the ports, which is from D4 to what, to D7. Then that's all you need. Okay, back to Proteus. Okay, we said RS is going to be connected to D2. D3 is going to be connected to E, which is EN. Then the rest of the ports from D7 is going to be connected as well to D7, D6 to D6, D5, D5 to D5, D4 to D4, D4 to D4. Okay. And the WR must be connected to the ground. It's connected to the ground. And we also need to pull up the MCRL to 5 volts. To 5 volts. So we are going to connect this to 5 volts, and also need I forgot something. Also need a resistor that is connected to the reset pin. Okay, we have our resistor. Of course, you may omit this and the simulation can run, but when it comes to the hardware, you face challenges there if you don't do this. Okay, there we have it. Then we're going to load our X file. Okay, it's set for it. We must have 8 megahertz. Then okay, my project was on the desktop. Yes, LCD interface in 4-bit mode. This default production LCD interface form there. Then we click on open, click on OK. Then we'll run our simulation. Let's see if we did okay. 4-bit fast libs. I don't know why it's doing that. Let me go back and check on my code. Oh, okay, I remember now. I remember. Okay, like I said before, if we have the LCD string function, it's just going to print wherever the last characters were printed before. So as you can see here, I'm printing LCD 4-bit. Then afterwards, I'm not clearing. That's why the VASLabs is going to print after LCD 4-bit. So to avoid this, I must introduce a what? Okay, let me just introduce this at the top. Okay, so I'm just going to introduce the LCD clear right here. The LCD clear right here, and hopefully it will solve the challenge. Okay, I compile again my program. Okay, build successfully. Then you go back to Proteus. Then you don't have to load anymore. Just stop the simulation. You run it again. Okay, VASLabs LCD 4-bit VASLabs 4-bit. Okay, now it's now behaving the way I want it to behave. Okay, here I notice that the delay is too small. I can as well increase it here by increasing this number. Okay, you must note that this number and the parameter of the MS delay is an integer, and we all know where the integers must. Then the maximum value of an integer, which is 65,000, 65,000. I don't really know, but somewhere there's 65,000. So you don't have to exceed that. Okay, we've finished our the simulation part and the programming part. We're going next on we are going to move over to the hardware interfacing, and we are going to be using the PIC3 as requested by some of the viewers.
Okay guys, so here I have my PIC, PIC3. So you place your PIC on the tray here, and you make sure that the MCRO pin is right next to this lever. Then you pull it down to hold the pin down. Then the MCRL goes to right next to the port which has this arrow. You place it right like this. Okay. Then afterwards, I'm going to connect it to my computer to program the PIC. Okay, as you can see, it lights up.
Okay, we are going to use MPLAB IPE. When you install your MPLAB XID to also be installed. Okay, so we open that application and you connect as we have connected our PIC. Then under this, you must select the PIC that you want to program using the PIC3. Then you select the two there, PIC3. Then you click on connect. Then it tries to connect. Okay, it's connecting. Just click on OK. Okay, it's connecting. Okay, we have to select the X file that one to program into our PIC. So you go to the location where you saved yours. I saved mine here, so I'm going to locate the file and open it. Okay, after that, click on program, click on OK again, and that bar over there comes. Okay, I'm waiting for it to program. Okay, we couldn't program it. We have to go under settings, advanced mode. You type in the password. Keep me logged in. Okay, you type in the password. Click on login. Then you click on power. You have to turn on this checkbox. Power target set from 2. Then you program again. Click on OK and again on this window pane. Okay, it shouldn't program. You see, as you can see, my USB port was providing 4.5 volts, so I have to change that here. Okay, I'm going to select 4.5 volts here for it to be compatible for programming. Okay, 4.5 volts, yes. Then I go back again to program. Click on OK again. Okay, yes, it's now programming. Programming verify complete. It means I've completed the programming. Let's move over to the hardware. Okay, this is the full setup of the circuit that we're going to use in order to display on our LCD. Okay, I'm not going to show you the actual hardware layout in the process whereby I'm going to lay out the circuit. I'm just going to show you the final product for time reasons. Okay, we have our positive here, our positive supply, which is the red, and the negative, the green. I assume you know how this regulator works. Then we have the potentiometer that is going to adjust the contrast on our LCD. Then we have this 12 kilo ohm resistor for the MCRL pin. Then we have another 10 resistor here, 10 ohm resistor here for our backlight pin, and everything is there. Let me zoom a little bit. Okay, so that is the layout of our pins on our PIC. So I think that's all you need to know. We'll now move over to the hardware implementation.
Okay, I finished up the wiring. You can check our previous video if you don't know how to wire this circuit. So I'm going to turn on the switch mode power supply. Okay, my LCD is not displaying anything. It's probably the contrast on the potentiometer there. Let me move my camera a little bit closer and adjust the potentiometer value. Okay, yeah, now it's displaying. So like in the code, we saw that it was flashing Vaslab's 4-bit, and I showed you where the problem was. You can adjust it. Yeah, there it is. How you can interface an LCD on a PIC microcontroller. So just an overview. We have the LCD, the potentiometer right there, and this is a 10K potentiometer. Then I have all the wirings. Then we have the 12K ohm resistor for the MCRO pin. Then I have a switch mode power supply that I'm using to supply this power to this circuit. Then basically that's it. If you follow everything up to what we said, you never go wrong.